statistics good practices, and this is the last section that we have about statistics. So if you have any questions, I told you, okay, we will see that on the next section. Be sure that I answer your question, okay? Otherwise, I mean, if I forget to answer your question, and just stop me and say, okay, how do we do this or that? So what we do here, we talk a little bit about cursor sharing and what should be the strategy for histograms, sample sizes, a column selection, table selection, and a summary. This is about the schema of the stats. Then what should be the strategy for system statistics, data dictionary, and fixed objects? That's what we cover. Some words about cursor sharing. We mentioned cursor sharing before. So what is this cursor sharing? Cursor sharing is a mechanism in which we try to reduce the memory footprint. By how? We want to use the same cursors. Keep in mind, the cursor is how we represent a SQL statement in memory. That is a cursor. So when we are sharing cursors, we're trying to reuse those structures in memory so we can scale our application. If we have only one user, who cares? But when we have thousands of users that issue the same SQL to the same forms with different values, we want to use cursor sharing. Now, if the application was designed to pass literals, that means our cursors are not shared. Every SQL with different values of the literals, we have a different SQL ID, therefore it will have a different cursor. That is very expensive, we don't want that. You, after 100 or 200 or maybe 300 users, your application is paying the price, it won't scale. You have issues. So you have to move to cursor sharing. Now, if your application is using literals, we have this parameter that is cursor sharing, which is like a band-aid solution. It's like a patch. It's like, okay, your application was designed to use literals instead of using binds. We can give you this option as a workaround until you fix your application. Fixing your application basically means change your application so it uses binds instead of literals. Is that clear? So we can see some applications, they live with cursor sharing forever and ever. It's not the best option. It doesn't perform the best. This is just as a workaround. With cursor sharing, we have three values. Value exact, which means nothing. It means like no setup. And then we have value force, and we have value similar. Value similar is be supported on release 12, so you don't want to use value similar for cursor sharing. Value force is still accepted, is going to be there for quite some time. It's going to replace those literals with binds. Now, once we replace literals with binds, we have the same issues we had before. Binds, histograms, skew data, they do not mix very well. You end up having unstable plans. So we have the same issue. This one here remains the same. So when we are forcing cursor sharing and we are on 11G, we will see multiple execution plans for the same SQL because adaptive cursor sharing can handle that. But if we are on 10G, we end up having unstable plans. Is that clear? So whenever we're forcing cursor sharing, in 11G we're fine, 10G we will have unstable execution plans, or plans that are changing over time. Let's talk about histograms now, or generation of the histograms. Keep in mind, histograms are controlled by this parameter. When we say method option on DBMS stars, on those APIs, this is where we specify how do we want our histograms. On 9.9, the default is no histograms. So that means if you still have applications on 9.9, who has applications on running on 9.9? One, two, couple of people, three people. Keep in mind, 9.9, by default, no histograms. So if you migrate your application from 9.9 to 11G or to 10G, and if you do not want to see surprises, you want to continue having no histograms. Now, when many customers were doing the migration from 9.9 to 10G, They were not aware of this. On 10G, the default is size arrow for the histogram. Size arrow, basically what it means is, if you have predicates where you make a reference to a particular column, that column is going to get a histogram. Okay? So customers that were going from 9i to either 10G or 11G, suddenly they went from no histograms to having histograms. That means our plans, they were from stable to unstable. Okay? So suddenly our customers were calling us and say, you know what? My application was working fine on 9i, we did an upgrade on 11G, and now it's erratic. Sometimes this SQL performs fine, sometimes the execution plan is bad. That was the reason. This changed here. Okay? So for the few of you that are still on 9i, just keep in mind, when you migrate, you want to continue having the statistics the same way you had before. It doesn't mean you gather the same way. You have to change the gathering because the default changed. Is that clear? Which was another misconception. Customers going from 9i to 10G, 11G, they were saying, oh, we keep gathering statistics the same way, and now suddenly the execution plan is breaking. Yeah, you're gathering the same way, but we changed the default. The default was making the difference. So some heads ups about histograms. Histograms, they only work on the first 32 characters of your column. It's very common today to see some columns that they contain like a URL, and the URL, the first 100 bytes or the first 100 are the same. So it makes no sense. When you have a long column, it makes no sense to generate a histogram. Now, with histograms, basically what we do, we improve the granularity. We're allowing the CBO to see a better granularity regarding our data, which is fine. It's fine in general. But when you combine that with big values, then your first plan is going to be optimal, but the second execution of the same plan may not necessarily be optimal. Just keep that in mind. When the data is extremely skewed, meaning you have some values with only a few rows, and if you gather it with histograms, depending on the sample size that we use, in some cases, we may miss that bucket. It may just disappear, the bucket. So keep that in mind. And another issue, another thing that we need to consider, whenever you gather with histograms, DBMS stats is going to take longer. So it's like, if you are willing to pay the price to have the histogram, is because you really benefit of the histogram. When you combine histograms plus adaptive cursor sharing plus binds, you end up having more plans, which is perfectly fine on 11G as long as none of those plans that you get is causing a regression. Every plan has like a small chance to be a poor plan, to be a suboptimal plan. When you allow a SQL statement to have multiple execution plans with ACS, which is perfectly fine, chances are is that one of those plans is going to be suboptimal. If that happens, the troubleshooting is harder, because not very easy you can reproduce that plan at will. Is that clear? Just something to consider. Now, if the application is using literals, that means you have no binds. Let's say data warehousing. Who has data warehousing here? Some people. Okay, on data warehousing, using literals is perfectly fine. You don't have to force cursor sharing or anything like that. It's desirable to have literals on data warehousing. Then in that case, histograms are perfectly fine. What I want to say here is data warehouse, having literals is fine, having histograms is fine. OLTP, having histograms, having binds on 11G is fine. On 10G, you have to be careful. It's doable, but you have to be careful. So what should be the strategy for histograms? Well, whenever method you use, keep them under control. What is the strategy for e-business? Who has e-business here? Nobody uses e-business? One person? In e-business, the way they handle statistics, or they handle histograms on e-business, they have this metadata that says, oh, for this particular column, I want histograms. But it's a small subset. They don't go ahead and gather histograms for every column. They only set up a few columns with histograms. they keep them under control. That is what it means here. Whenever you have histograms, just keep them under control. When you have a table that has many columns and you want histograms in only one column and everything else no histograms, you use this syntax. You say, for all columns, size 1, comma, for columns, the name of the column, size 254. And this is plural here. Even though it's only one column, it says for columns, and then the name of the column, size 254. If you have a couple of columns that you want to have histograms, you can collect this way. For all columns, size 1, for column, size 254, and then the list of columns that you like. So one shot, gather stats, no histograms except for 1 or 2 columns. Now, if this is a new application, or you're coming from 9i, or there is no clear need that you need a histogram, you better stay away from the histogram. The way I see histogram is, don't create a histogram unless you know you need a histogram. That means by default, stay away from histogram. That is what I suggest here. It's more conservative. When you are dealing with this method option, you can use this method option in gather table stats. So that means every time, like imagine that you decide to put a histogram in 2 columns here. That means every time you gather stats for this table, you keep this parameter, or you put this on a script, and you always run the same script. That's one way to do it. The other way to do it is you set table preference and pass this value for this one table. So you do it once, and then every time you collect, you just say gather table stats, and you don't have to pass the same parameter. Is that clear? So you pass it once or pass it many times. It's all a matter of how you prefer to do this.
A question?
Yeah, go ahead.
Going back one more slide, you say buckets can be missed with, when you have small cardinality values, but, does that really hurt you in practice?
Yes, it does. It does. Let me explain why. Let's take this as an example here. Imagine that we have 1, 2, 3, 4, 5 distinct values. And for this value, we only have a couple of rows among 1 million rows. Okay? If our sample size is small, sometimes this bucket disappears from the statistics. So when that bucket disappears, and the predicate that we're using is when column, the name of the column, equals this value, and the value doesn't exist, the CBO has to compute selectivity and cardinality anyway. So what it does, it takes the next bucket, which is this one here, and it takes half the size of that bucket, and that is the cardinality that it assumes. So imagine this one here has 2 rows, and this one here has 2,000 rows. So when I have the bucket, when I have my predicate that says column equals this value, it computes the cardinality as 2. But if I don't have the bucket, it computes the cardinality at half the size of the next bucket in size. So in this case, if this one has 2,000 rows, half 2,000 is going to be 1,000. So the CBO is going to miscompute cardinality by a big margin.
Is that version dependent?
Yes, that happens on 10.2 or 4 and higher.
Thank you.
No problem.
So does that mean that it's not based on size, it's more based on where that value fits in between?
No, it's not in between. I mean, because if it finds a bucket with that value, it's fine. But when it doesn't find the bucket, it has to use a heuristic, which is basically a rule. The rule today says when you don't find a bucket, take the smallest bucket that you find, half of it, and assume that the value that is missing will have as many rows as have that smallest bucket. If the smallest bucket has only 4 rows, you're fine. But if the smallest bucket, in this case one here, has a couple of thousand rows, then it's totally off. So those are the extreme cases where you see my plan is changing over time. Sometimes I see the bucket, sometimes I don't see the bucket. And the cardinality goes from a couple of rows to a couple of thousand rows. Okay? So going back to sample size, yeah, we finish here? Yes, we finish here. Sample size.
So, is there a case where we lock the histograms, generated lock it not to?
Locking statistics.
Yeah,
Uh-huh.
for the building the stats for the, build the histograms and where we say log them and not to rebuild every time.
Okay, I think it's a pretty common mistake, I want to say mistake, to lock the statistics when we're looking for a stable plan. Let me try to explain why do I say mistake. I have seen this on many DBAs, and I may even adventure to say like maybe half of the DBAs, when they're looking for plan stability, they may consider locking the statistics. Saying, okay, my statistics are fine, I can see a good plan, I'm going to lock the statistics, so my plan doesn't change. That is a false sense of security, because guess what? Your plan is going to change. Why your plan changes even if you lock the statistics? Think this way. It's very common on any table that you have these two types of columns. A column that the data is created based on a sequence. For example, a numeric primary key, right? Primary key, value 1, 2, 3, 4, 5, and so on. And you also have this type of column that is based on a date. Could be creation date, expiration date, could be booking date, whatever date, okay? If you have predicates on one of those two, well, even if you lock the statistics, your data keeps changing, so that means your sequence continues growing, right? And the other one is about the date. The date, sysdate, is changing. So because sysdate changes and your sequence changes, when you are selecting data from your table and you are saying where this date is between yesterday and today, if you execute the same SQL 1 week later, that yesterday and today has a different meaning than today. Is that clear? So that means your statistics are frozen, they are not changing. Low value and high value, they remain the same, but the window you are searching is changing over time. So that window is going to be out of scope, it's going to be out of ranges. Is that clear? You remember that I told you this morning, I said low value and high value for every column is very important. It's very important because of this. When you have predicates that they fall outside range, your plan is going to change. So if you feel like you are locking the statistics because you don't want your plan to change, guess what? Your plan is going to change. It may not change tomorrow, but it will, sooner or later it will change.
Okay, so if I address that, I mean, if I don't gather statistics on a table, but I address what you just mentioned by updating low values and high values manually, am I safe, assuming I know what I'm doing?
Exactly. That is, yes. When you are changing the statistics yourself, that is the difference between hacking the statistics or enhancing the statistics. Because keep in mind, the CBO is going to be using whatever statistics we have there. If you know better your data than DBMS stats, if you modify the statistics in such a way that they do represent the data better, you are perfectly fine. You are enhancing the statistics. Hacking the statistics is not knowing exactly what's going on and just tweaking them to show whatever plan you like. That would be hacking. But enhancing the statistics is perfectly valid. And guess what? That is a lot faster than gathering the statistics. So it's valid, is allowed, is support. We have an API to do that. We have the set system, set column stats, we have set table stats. We have all those APIs to set the statistics. If you know what you're doing, that is perfectly supported, that's perfectly valid. Good point. Any other question? Okay, so when we specify the sample size, we say the sample size, we use this parameter, estimate %. And on 9.9, if we go back to the case of 9.9, the default was 100%. So that means when you were gathering statistics on 9.9 and you would not specify estimate %, it was using 100%. Also known as compute. But now on 10G and 11G, the default changed and it's using this out of sample size. Out of sample size, basically what it means is it's going to take a very small sample size. No more than 5,000 and something rows. In most cases, that is enough. Even though your table has like 1 million rows, we read the 1 million rows, but we analyze only like 5,000 rows. In most cases, that should be enough. Most cases, but not in all the cases. Now, on 10G, when we were using that small size, we had some issues here. We had some bugs with the number of distinct values. Bugs in the sense that this value was not that accurate. It was good, but not that good. So that means on 10G, when we were using this out sample size, the quality of the number of distinct values was poor. Therefore, once you have a poor quality on the statistics, the execution plan in some cases may produce a suboptimal. It may be suboptimal. That was normal. That was not normal. That was common on 10G. On 11G, it's using a new algorithm, which is more efficient and is more accurate here with the number of distinct values. The number of buckets still requires some improvement that is fixed on 12C. Okay? So 10G, with this out sample size, we had a number of distinct values where the quality wasn't quite there, and the number of buckets wasn't quite there. 11G improved here, and this is critical. The number of distinct values, we use it all over the place. So 11G improved a lot here, but it still needs some improvement with the number of buckets. 12C is better. Any questions there? Okay, so some heads ups regarding the sample size. If your data is not skewed, a small sample size and no histograms, you are perfectly fine. You are totally fine. Now, if your data is skewed and you want a histogram, you want to consider a larger sample size. This is especially true on 10G. Now, keep in mind that whenever you gather with a larger sample size and on top of that you have a histogram, it's going to take longer. So it's always a trade-off. Either you invest more time in gathering statistics and you get better quality on your statistics and therefore better plans, or you gather stats faster, lower quality, and lower quality of your execution plans. It's always a trade-off. Because in the perfect world, we want everything perfect, right? So we would like to gather 100% all the tables daily. In real life, we cannot do that. In real life, we have to live with the kind of not the best quality of the statistics, but something that we can manage, maybe gathering once a week, maybe once a month, and not necessarily with 100%. But we know that we have to pay a price, and the price means we will have some suboptimal plans. Let me ask you this question. Just one second. Let me ask you this question. Imagine that we have this application with many SQL statements, but we know our SQL statement. We know the SQL statements that are sensitive, that are critical for our business, and we know when we see those SQL statements, we know, okay, this is a good execution plan, this is a bad execution plan. What if I take that execution plan and I pin the execution plan? Somehow, I pin the execution plan. In that case, does it matter what is the state of the statistics or not? It doesn't, right? So if I have the technique to get a good plan and pin the execution plan, the state of the statistics is like second priority. It's not as important as it used to be, right? So that's something you also need to consider. Instead of being like so obsessed, getting statistics perfectly every time, is whenever you have these business critical SQL statements, if you get to pin the correct execution plan, then the gathering of the statistics, which will affect every single SQL, it may not be as relevant because it shouldn't be affecting your SQL. Okay?
That's what the tuning and performance part does, right? You ask for the new plan, you say the new plan, and you say go and implement the new plan.
This is where SQL plan management helps. SQL profiles, they come in two flavors of SQL profiles. You have SQL profiles coming from the tool advisor, where you create a profile, but the profile has a dependency on the statistics. So that means it's going to be more stable, but it still depends on the statistics. Meaning, you change your statistics dramatically, your plan may change. So it's not 100% stable. Okay? And there's another way to do that, to put an outline on the profile. I will talk about that in the afternoon, how to do that on 10G. On 11G is easy because we use SQL plan management and we achieve what we want, which is basically a stable plan. It doesn't change, has no dependencies on the statistics. On 10G is a little bit harder, but it's doable. Okay.
If you have automatic statistics gathering,
Uh-huh.
at what point do we decide, okay, maybe that, even if we are performing, I don't know, optimally, but without too many problems,
Uh-huh.
is there, the frequency of gathering is no longer a thing, right? It's the database is deciding that.
Okay.
That point.
The frequency of the gathering, when you're using auto, is going to gather your table, going to gather size of your table when the statistics are stale, meaning when they change more than 10% of the rows. That may happen daily, that may happen every once per month. It depends how much you change your data, okay? There are some caveats with that, because if your application is highly integrated or highly integrated data from different tables, let's say your application uses these 3 tables, well, they will become stale at different points in time.
Yeah.
So it may happen that one table becomes stale daily, the other one becomes stale like every week, the other one becomes stale like every month. So at any given point, you will have different states of the statistics. Could be perfectly fine, but it could be one of those cases where you are borderline, when you have this one is stable, this one is not, and this one is, you may have a fully performing plan. So when you disconnect the gathering of the statistics from the application, you may end up having some situations in which your plan is going to be suboptimal. But you don't have control of that, because once you have this like asynchronous, I mean the gathering of the statistics and your application are asynchronous, you may find that kind of situations. Okay, so it's something that you need to consider. Okay, so any other questions so far? No? Okay, so the challenge here is to determine what is the right sample size, what is the quality of the stats I want, and what is the frequency that I want. It's challenging because it's always a trade-off. You can increase the sample size, but if you increase the sample size, it's going to take longer, right? So maybe if it takes longer, you don't need to gather that often. Anyway, so what is the strategy that we suggest here? Well, if there are no histograms, on 11G, just go ahead and use the auto sample size. You're perfectly fine. No issue. It's fast, it's good enough. Auto sample size. If you are on 10G and you have no histograms, then you can go. Okay, if you're on 10G and you have no histograms, you can go with a fixed value. Let's say you can do 30%, 100%. You're fine, no issue at all. Now, the issue is when you have histograms. When you have histograms, our sample size on 11G is also fine. So in other words, our sample size on 11G, you're fine. It doesn't matter you have histograms or not. This is what it means. But on 10G, when you want to have histograms, you want to try 100% if possible. If possible, gather with 100%, gather everything. If not possible, then do at least 30%. If not possible, because your data is so large, then try at least with a 10%. Okay? And this is not written in stone, but we have seen over time that on 10G, if we have histograms, you are shooting for this. You are trying to do 100%, if possible. This estimate percent, which is to set up the sample size, you can specify that as a gather table stat parameter or as a set table preference. The same as the other one. On 11G, you may want to use the table preferences. On 10G, we have something similar to table preferences, but it wasn't that widely used. So anyway, you can use it, to set the preference once, and then every time you gather, you use the same values, or every time you gather, you pass it. What I have seen customers doing, they put everything on a script. So they have the script, they run the same script. It's perfectly fine. Now, regarding columns. You know when you gather statistics, you can specify for all columns, or you can specify for all index columns. Which one do you use? Who uses for all columns when you gather stats? Nobody? Who uses for all index columns? 3 people. 4. Okay, and everybody else, what do you use when you gather stats? For all columns or for all index columns?
For default.
Or the default? You use, okay. We have the option to say for all columns, for all index columns, for all hidden columns, and then the size comes here, comes afterward. This is just to select the columns. when we say for all index columns, Civil application is using this technique for all index columns. Why? Because Civil has this rule that says whenever you have a predicate, you must have an index. That is a rule for Civil. So if that is the case, when they do for all index columns, basically what they are saying is for all the columns where I do have a predicate, which makes sense, unless, of course, we end up having some predicates with no index. Personally, I don't like this one for all index columns because it is assuming that you have an index on every single predicate. In reality, it doesn't happen. So you end up having columns. When you say for all index columns, you end up having columns with either no statistics or outdated statistics. Is that clear? When you use this technique that says for all index columns, what happens for in those columns where you do not have an index? You have no statistics. Or you end up having outdated statistics. Some statistics that you gathered 3 years ago, they are still there. Nobody's going to wipe them out, right? So you have a mismatch. You will have some columns with statistics and some columns with no statistics. Okay, when you gather in all columns, of course it's going to take longer than if you gather on a subset of columns. That is common sense. How do we know if a column is used by a predicate? We look here. Assist column usage. This table is going to tell you if any given column on any given table has been referenced in a predicate. Okay, that is what we use. On linear stats, this is what we use. So what would be better on a column? Having no statistics or having outdated stats? Imagine that you are doing the for all index column. So which one of these two is better? No statistics? Why do you think no stats is better?
Because in our environment for the SIBO, sometimes using the dynamic sample size, you can get a better plan. Because if it's really outdated, it's really, really bad.
Yes, but there is a misconception here. When we have statistics for other columns, then dynamic sampling doesn't kick in. Dynamic sampling only kicks in when we have no statistics for the table. But if the table has stats, but it has some columns with no stats, dynamic sampling doesn't kick in. So that means if we have no statistics, it has to guess. And whatever value it guesses the same values for every column. So it's like one size fits all. So in that case, it's better to have outdated stats than having no stats. Of course, it's much better to have real stats, good stats. Second best is outdated. Third is no stats for a column. So what should be the strategy? Well, consider this popular and what used to be a political correct measure, like no column left behind. Okay, it's not popular anymore, but it was very popular a few years ago. So that means even if the column user says that we have no predicates, it doesn't matter. Gather stats because you never know. You never know the next day someone is going to write a SQL on that column and is going to reference that column and you have no statistics. So it's better to collect on every column. So that means use this method for all columns, which by the way that is the default for all columns. I'm not saying anything about the size. For the size, which is if we want histograms or not, we can say size 254 and the column that we want, or we can say size 1 for all the columns and then 254 for these columns. Or we can use size auto. Or we can use skewed only. I do not recommend the skewed only. Who else uses skewed only? Skewed only for size. Size here, there is one value that we can say skewed only. What I have seen with the skewed only is that it generates histograms for many columns for which the data is actually not skewed. So it gives you the impression that it's going to generate histograms only when needed. In reality, it generates histograms in many more columns. It's like in that case, I'd rather decide which columns are skewed and I want histograms and not let the engine decide because the engine is going to overdo it. Okay? Just check it out. In any of those tables that you are saying is skewed only, look at all the columns that you have a histogram and then do a group by on that column and see the data, and you will find that many of those columns are actually not skewed. Okay, but still you have a histogram, which of course that takes longer because you're creating histograms in columns where you don't need them. Now, when it comes to tables selection, I mean, how do you determine which tables? Because again, in the perfect world, we say collecting every single table, right? But what we cannot collect every time that we gather stats. How often do you gather stats? Daily? Daily? Weekly? When you say daily, do you mean all the tables in your application, or
We only capture those stock tables.
the table that is stale?
This time, yeah.
Perfect. Perfect. That is good. I mean, you can do it daily as long as you only focus on those that are stable. And when you do daily, you do it like once per day, or you do it a day? Once per day. Okay. Usually during low volume. I mean, perfect. That is perfect. That is the way you can do it. Well, keep in mind, tables, they come in different shapes. I mean, there are small tables, large tables, tables where the data changes a lot, tables which are pretty static. You have all types of tables. You have global temporary tables, you have partition tables. So how do we gather them? We want to use these DDA tab modifications. In these DDA tab modifications is where we keep track if the statistics are stale or not. When we use the DDMS stuff out of job, is based on this one here. So you can also write your own job to gather statistics based on the same view, and you will have more control. Okay? So when you use this auto job, it's going to be looking at DDA tab modifications, and any table where the statistics are stale, basically meaning more than 10% of the rows have changed, then we gather stats there. Another way to do it, or it can be concurrent, you can do both. When you are dealing with small tables you can do it more often. Why? Because they gather really fast. So that means even if you change less than 10% of the data, you may want to do it. Why? Because they are almost free. They take very little resources. So you have more accurate statistics with almost no cost. Now, when your data is changing constantly, you have three options. And it doesn't matter how you name these options, those are basically the three options that you have. You either implement a process, that means your application needs to be smart and say, whenever I load data into this table, I gather stats. I change the data, I gather stats. That is one way to do it. Another way is I delete the stats on those tables, I log the statistics, meaning no statistics at all, and I'm going to rely on dynamic sampling. And the other method here is I review my application, and when I have a normal load, I gather the stats, I log the stats. But if I use this technique, I need to be doing this every once in a while because the low value and the high value are going to be outdated. So which method you think is better in general? The first one. The first one is the best method, but it requires. Why this one is better? Because this one is synchronized in your application with the gathering of the stats. It's better if you synchronize these two. This one you rely on dynamic sampling, and dynamic sampling has some constraints. We have some concerns with dynamic sampling. Usually the sample is too small, therefore the quality of the statistics may be poor. And this one requires to be doing it often, right? You have to redo this every once in a while. But this one is more like asynchronous for your process. In general, I would say this one is better, but it requires a change in your application. Normal. Okay, when you have partitions of sub-partition tables, you usually want to gather global and partition. Why? Because of the number of listing values I mentioned before. Unless you're 11G and you have large tables and you may want to use incremental stats on 11G. If we're dealing with small tables, we may want to do this is SIBO. SIBO with small tables, they delete and log statistics. Why? Because dynamic sampling, even though we read only like 32 blocks, well, a small table is going to fit on those 32 blocks, which means we're going to gather 100%. Okay? So the technique that we use on SIBO that says small tables, we delete the statistics and we log them, and we define small tables, anything that is less than 100 rows, is okay. It's okay. It has some overhead. Yes, it has some overhead, but it's perfectly fine because when we do the dynamic sampling, we consider 100% of the rows. Okay? Now, as the table is bigger and bigger, we may want to do a smaller sample size and we may delay the gathering. This is one way to do it. Another way to do it is using the scale, or you can combine the two of them. When you overlap these two, that should be fine. I mean, if small tables, you do it more often, even though the data is not stale. Why do we care? Imagine that we are here. Tables which are between 100 and 1 million rows, the data is not stale, meaning we haven't changed more than 10% of the rows. And here we're saying, you know what? You may still want to do it like every 3 weeks. Why? Why so? Even though the data hasn't changed.
Maybe the high and low values change.
Exactly. Low values and high values for those columns that are coming from a sequence, or those columns based on dates. Your table is not stale, but those columns, the low value and high value, they are out of range now. So even though the data is not stale, you may want to implement something like this in addition to the stale. Is that clear? Okay, so summary so far. If your application vendor, and when we say application vendor, that could be eBusiness, that could be SIBO, that could be PeopleSoft, or any other application vendor, if they have a process to gather statistics, you can go ahead and use that process and you're fine. In general, stay away from the histograms unless you have a reason to gather a histogram. With NG, our sample size is fine if you have no histogram. Remember, on 11G, our sample size is fine, either with or without histogram. Don't leave columns behind, so that means gather statistics in all the columns. If the table is changing, if the data of the table is changing constantly, you may want to implement one of the 3 options I showed you there. When the data is stale, gather as soon as possible. With partition objects, gather 2 levels. Smaller tables, gather more often. That is the summary so far. What about system statistics? Shall we collect or not collect system stats?
Yes, correct.
Yes, collect. I would say, all things considered, yes, we want to do it, but we want to do it at the right time, and we want to do it with the right API. So that means you want to do it in 2 steps: start and stop. And you want to do that. And we want to do that when you have a load on your system. So that means you do the start, let's say Monday at 9 a.m. in the morning, and you do the stop Monday at noon, like 3 hours interval. Is that clear? And when you do that, you want to verify the quality of those statistics. So you got the statistics, you verify the quality. If the numbers are reasonable, fine. If they are not reasonable, delete them. Okay? System starts. How do we gather them? We say start, stop, and with an interval between 2 and 3 hours during normal load. How do we review the values? We just execute the SQL and look at the values. The values should be reasonable. We pay special attention to single read time and multi-block read time. In some cases, we see that the single read time says 4, multi-block read time says 3. No sense. It makes no sense. How is it possible that reading a multi-block, that doing a multi-block read, it will take less time than a single block? It makes no sense. So you have to do a sanity check. What about the data dictionary stats? Data dictionary stats, yes, we want to do this. On 9.9, you have these 2 different opinions. You have some people saying, yeah, we want to do them. And some people will say, no, we don't want to do them. So in 9.9, I would rather say, no, don't do it. Don't do it on 9.9. But if you are on 10G and 11G, the recommendation is to do them. But when? When do we do this? When shall we do the data dictionary stats? How often?
When there is significant change.
Significant change of
The number of objects are added.
objects on the data dictionary. Yes. So that means, for example, you did an upgrade. During an upgrade, we create many objects, we change objects, that's a good time to do it. Or you either eliminate or create many dictionary objects. If your application creates like thousands of tables and then drop thousands of tables, then you have to do it more often. I suggest here to use an auto sample size on 11G, and if it's on 10G, instead of using the auto sample size, use 100%. It is fine if you do this, putting histograms in the columns that are used. So look at this code here. It says, for all columns, size auto. This size auto means if the column is referenced on a predicate, go ahead and do it. Okay? Estimate percent, 100% on 10G, fine. On 11G, don't put this parameter, just leave the default.
So in the system stats, is the no workload option worthless?
I would never use that. The no workload, I never use that. The reason is when I have used that on test environments, the quality of the statistics is poor. And the workload is not like it's gathering all the time. The workload is taking a snapshot at the beginning, 3 hours later, take another snapshot. There is no resource consumption in between. So that means the calling the API it takes just a fraction of a second. Calling the API again is taking a fraction of a second. In the meantime, it's doing nothing. Just take a snapshot of system stats at the beginning and at the end, and then compare them and create the system stats for the database. So there is no overhead. So don't use the no workload. Fixed objects, fixed object stats. These fixed object stats, those are the ones that they are on $X tables, which are the ones behind the $V views. I mentioned this whenever you have poor performance on AWR or Enterprise Manager or any other tool that is monitoring performance. If you notice the tool itself is performing poorly, you may suspect fixed object stats. Now, these fixed object stats, there are some heads ups here. They rely on a lot of latches when you collect fixed object stats. So if you do fixed object stats when your system is up and running, everybody's working, is peak time, you may hang your system. Okay, so just be careful. You don't want to do this like in the middle of the day. You don't want to do that. So,
Question. The same thing for GB dollar tables also for rack?
for GB dollar tables,
GB dollar views, GB dollar.
yeah, GB dollar would be the same. Yes, yes. So how do we want to do this? Well, gather only once after an upgrade. So that means don't do it like every week or anything like that. No, there is no need. Only when the workload on your system changes drastically. Let's say now you have a major implementation and you have double the users. In that case, you want to gather fixed object stats, but just be careful when you do that. I suggest to do this at the end of a working day. So that means at 5 p.m. when everybody is going home, you can do it. Why? Because your system is still warm. That means you still have a lot of data and memory to gather good stats, but you may not affect your users. So just be careful. When you gather fixed object stats, don't do it at the beginning of the day, do it at the end of the day. And when the system is still warm. Okay? Hey, you want to add something here with fixed objects?
In the manual, it's documented that it is not recommended to join these $V views, actually. If you're going to do queries on $V views, to do them only on one view, not doing joining. Now, the fixed stats are going to help you to do all those joining stuff. But also the problem, and Carlos makes a very good point, that it should not be done while you have your normal production, because of the when you access those views, sometimes you use latches, you use mutexes and stuff like that. But here is the other part of the question. Many of these views are only populated when you have a load. So if you gather statistics when there is no load, there is nothing in them to show, So then the execution plans at the end are bad. It has been several attempts to try to come up with a good solution regarding $V views. We still do not have it. So, yeah, my personal opinion is leave them alone. Don't gather them. And I mean, it's very, very often that Carlos and I do not meet eye and eye on a particular subject. It's perfectly fine because, I mean, tuning sometimes is an art. And as an art, we're entitled to have different opinions and depending on our own experience. In support, I do not see the good, I only see the bad and the ugly. So I can only speak about that. But what I can tell you is that what is supported is that you only query $V views alone, not joining them, not do weird stuff on them. If you need to do weird stuff on it, with complex joins or complex queries, it's better that you do a create table and select from it, and then you do whatever you want on your table. It's not necessarily practical. Fortunately, that is what development says, that is the only supported way for doing it. RBAN is particularly susceptible these statistics. And you cannot gather statistics on a system that is an ASM instance, or sometimes when the database is mounted or stuff like that. It becomes very problematic to handle queries that have slow performance when you're working with RMAN. So that, to me, that is also another point it's better not to have them. Development will find some way to help you out if there is a problem with them. So my point of view is better leave them alone and not use. There are other stories that I should not share anyway.
Yeah, well, go ahead.
So
Thank you.
what's your recommendation with running system stats on Exadata?
System stats on Exadata. And he's the Exadata guy, so let's see what you.
Yes.
Okay. We could use the Exadata for Exadata?
Yes. But we have not fully tested the whole extension of it. I have not heard any bad things about it. But then again, I only hear the bad and the ugly. So far, no. So far, so good. I mean, the testings and so that, I mean, it has been promising, but we have not gone into too much depth into looking at the changes. Apparently, I mean, the change is very simple, actually. It's not very complex. It's only, I mean, adjusting parameter for the DB file multi-block count. And that's about it. But sometimes they build on top of that little changes and make some additional adjustment. Anyway, on Exadata, it is statistics. I mean, still are important, but not as such an importance. The execution plans, depending on what is the objective that you have for your database. For data warehousing, they start to be less and less meaningful because the execution plans that you're going to have are about the same. You have joins with full scans. And that's about it. So the statistics are more relevant if you want to choose between indexes and full scans and stuff like that. Order of joins. Due to the smart scan, those execution plans tend to be a lot simpler and also not very intuitive at the first time that you saw it, but it's because of the smart scan. So that, I mean, the Exadata tuning aspect, sometimes is a little counterintuitive. Yes.
Yes, going back to system statistics, what we've done since 9i is to set system statistics to what we consider typical values at our customer sites. And the reason for that is predictability, knowing that the execution plans, that we've tested in-house will, work the same way at customers. I realize, there may be some things that are suboptimal by 10, 20, 30%, but we're trying to avoid anything catastrophic happening. Do you see any, any problems with that moving into newer versions?
Not at all. I mean, setting, if you know the values that work for your applications, your customer, it's perfectly valid, I mean, to use those values. I don't see any trouble with that.
It's perfectly valid and supported.
Thank
Yeah.
you.
But also, von Neumann said that it was, one test is worth 1,000 expert opinions. So, I mean, whatever works for your system, and period, no matter how many other people's opinion.
Okay, just wanted to be sure, there wasn't something creeping into newer versions that would hurt us.
No, still supported.
Okay, so let's finish here. So some reference here, we have some notes. I mean, you have these numbers on your materials in case you want to drill in a little bit more. Some documents, some of these documents are here on references, they are included in your material. One of the folders, it says references. I don't know if you noticed that when you're looking at the material here, for SQL Tuning Workshop 1 or 2, they include this section that says reference. And several of these are there. For example, just to give you one, to read the execution plan, if you're still struggling understanding the execution plan, you can take this one here, which is more than 10 years old. When I wrote this one when I was part of the COE for e-business, year 2000. But it still is valid. I mean, how we read the execution plan. So it goes, I mean, how do we read the ticket prop, different columns on ticket prop, and then it goes through examples. How do we interpret the execution plan? So all those documents are included. Whenever we say, okay, we have the reference, the document is also there. So with that said, we finished this section. It's almost 12. Is this a good time to break for lunch?
Yeah, that's when they were told to.
Oh, perfect. By the time it will be just fine. Okay, so let's break for lunch.